Okay, today's notes. We are learning another panic and phantoms. We are going to do a phantoms together. I will give you the panic formula, and then you will do an example in your group at the end of class. Today, we are looking at what's called matched pairs. Matched pairs still has to do with mean. So we are still looking at scenarios where we have two samples, and we are looking at mean. The difference with matched pairs, though, compared to what we've already done, is with matched pairs, we have two samples that are dependent. Best way to see this is just to look at an example. The table below gives the pre-test and post-test scores on the MLA listening test in Spanish for 20 high school Spanish teachers who attended an intensive summer course in Spanish. So from the data, you can see the subject number, every subject's pre-test score, and post-test score. You then will notice that we have some output, some computer output with summary statistics. There are three different variables that we have summary statistics for: the pre-test, the post-test, and the differences. The difference would come from finding the difference for every single subject. So if we subtracted for every single subject, so the first one, we're doing post-test, subtract pre-test. So the first one we would get -1, then we would get 2, then we would get 1, and so on and so forth. That's what the differences comes from. That's where this data then comes from. So it would be the mean of all of the differences, the median of all of the differences, so on and so forth. And then we have dot plots for all three sets of variables. Again, pre-test, post-test, and difference. We okay on the context so far and what we're looking at? Okay, the question we're answering is at the bottom. We hope to show that attending the Institute improves listening skills. Carry out a full hypothesis test. If we look at the data that we were given, if we were to carry out a two-sample hypothesis test, we would need a random samples, and we would need samples that are independent. If you notice here, our two samples, our pre-test and post-test, are those two independent? Are the pre-test scores that were chosen independent of the post-test scores that are chosen? Should be very clearly no. Why not? Why are they not independent?
Because you're taking the same test twice, or a similar test twice.
It's the same person. The same person that took both tests. So if I was chosen to take the pre-test, I have to take the post-test. So these two samples are not independent. Is that clear? So a two-sample procedure would not be appropriate. That's why we have to do matched pairs. Before we actually carry out this test, I want us to write down real quick when we do matched pairs. Matched pairs, or sometimes you're just going to see paired procedure. And this is used when the samples are dependent or paired. It's important for you to be able to recognize when the samples are dependent or when they're paired so that you know to do this matched pairs procedure. And so there are some typical pairings or typical ways that subjects are paired. The first one is like the example that we have when you have the same subjects. So in our case, every teacher took a pre-test and took a post-test. That is a typical way to pair. Second typical way to pair is naturally occurring pairs. So, for example, two people within a couple, maybe twins, siblings. What would happen in this case is, let's say you have a pair of twins. One twin gets one treatment, the other twin gets the other treatment. So oftentimes this matched pairs comes up in experiments. Same thing with a couple. One person gets one treatment, the other person gets the other treatment. Last pairing is what's actually called a matched pairs. Often in the case of an experiment. Do you all remember what a matched pairs experiment means? I would venture to guess no. Do you remember what blocking means in the case of an experiment? What is the purpose of blocking in an experiment?
Confounding variables.
To control confounding variables. And so within each block, all your subjects should be similar to each other. Half the people get one treatment, half the people get the other treatment. Okay, in a matched pairs experiment, it has blocks, but your blocks are of size 2. So you have a whole bunch of blocks of size 2. In each block, those two subjects are as similar as possible to each other. One person gets one treatment, one person gets the other treatment. The ones that you are going to see most often are the first two. So you need to be able to recognize my samples are dependent, hence a matched pairs procedure is appropriate. That's the background. So we're going to go back to our hypothesis test. We want to know, did attending the institute improve listening skills? So that's what we're going to answer. Sound good? Okay. Here is the first difference, the symbol. We are still looking at mean, but we need to somehow indicate that we are looking at the differences. We're not looking at pre-test, post-test, we're looking at the differences. So we are going to say, let mu d be the population mean difference in scores on the MLA listening test, I think. Does that sound right for context? I can't go back and forth, so. Yeah. Okay, great, thank you. Okay, what you also have to do is, I brought up with 11.1 that if you define your variables opposite of what I do, everything's going to be opposite sign-wise. And so you do need to tell me how you plan to subtract. So in our case, I think it makes most sense to do post-test minus pre-test. So I would say D is post-test minus pre-test. Okay, so then we're going to look at our null and our alternative, which will both be in terms of mu d. The vast majority of the time, you are assuming that there is no difference. We want to know, did attending the institute improve listening? If it improved listening, then the post-test scores should be higher than the pre-test scores, which means that mu d should be greater than 0. Okay, assumptions. What is our first assumption always? Random. Okay. If we look at our variable, mu d, that means everything is in terms of d. I'm not checking assumptions for pre-test and then separately for post-test. I'm only checking assumptions for differences. So when I say random sample, it needs to be a random sample of differences. So there is a bunch of differences that were calculated. We took a random sample of them. So random sample of differences. What is the second assumption for mean? %% rule. Yep. I'm going to do that one last. What else is there? Sampling distribution is approximately normal. You know how for a 2-sample procedure we checked that the samples were independent? Okay, instead of independent, we also need to check that the samples are paired. So that is assumption. Are the samples or sample paired? And we are going to say yes, because we have the same subject. So then, like Ela said, for the third assumption, do we have an approximately normal sampling distribution? This is the sampling distribution of differences, not of pre-test and post-test, but of the differences. Our sample size is 20. We have 20 differences, so we can't use the central limit theorem. We don't know anything about the population. We do have a dot plot of the differences. Does it look like there's extreme skewness or outliers? No. So I'm going to say, since the sample of differences does not show extreme skewness or outliers, then I'm going to just reference dot plot. The sampling distribution is approximately normal. Again, this is something on the test that some of you messed up, is sample versus sampling, so just please be cognizant of that moving forward. In our case, 10% rule. Not necessary. Why not? Normally it is, but why is it not in this case? What? Okay. 10% rule is necessary when we sample without replacement from a finite population. Which of those is not the case here? Did we sample at all? No, it's just the 20 teachers that took this institute. So there was no sampling done. So don't need to check that one. So now we are on to N. This is called a matched pairs hypothesis test. It is upper-tailed. Alpha is going to be 0.05. And I'm using T with 19 degrees of freedom. 19 degrees of freedom. And that's because we have 20 differences. 20 minus 1 is 19. Theoretically, not theoretically, we could be using Z. Very rare. When would we use Z? When you know the population standard deviation. Population standard deviation. Which, again, is pretty much never. Okay, test statistic. This is one you've already seen before. It is the same test statistic for mean when there's one sample. So mean, when there's one sample, we do sample mean minus population mean, all over S over root N. The only difference is that you put a D in there to know that we are looking at differences. All of this information we can find from the output on the previous page. So the mean of the differences is 1.45. Mu d, which comes from the null, is just 0. Standard deviation is 3.203, all over the square root of 20. Please find that right now. Believe you should get 2.02. Okay, any questions before I keep going? Laura? When you do number 4 for assumptions, should you put what?
ND. Like N and then D with the subscript.
Ah, I'm with you. Ideally, yes, you would. Okay, let's draw our figure. So here are just our standard labels. Our assumed difference from the null is 0. I'm going to label my test statistic of 2.02, and this is upper tailed. The standard deviation is everything in the denominator, not just 3.203. So that ends up being about 0.7. So then the only other thing to label is this actual sample mean. So that's 1.45. We okay on the figure? Yeah? Okay, so we are finding the probability that t is greater than or equal to 2.02. On your calculator, that's TCDF, not normal CDF. Some of you got yourself in trouble on the test by using normal CDF instead of TCDF. If you remember, for TCDF, you need lower bound, upper bound, degrees of freedom. So I get a p-value of about 0.029. Okay, at this point, we're going to make a decision and write a conclusion. Our p-value is less than 0.05, so we are going to reject the null. We have 3 sentences to write. Reject the null in context, interpret the p-value, and then of course we actually have to answer the question. Based on my analysis, I reject the null. And instead believe the population mean difference in MLA listening scores post minus pre is greater than 0. Interpreting our p-value, 0.029 is the probability of obtaining a sample mean difference of 1.450 or greater, assuming the population mean difference in MLA listening scores is 0. Okay. So then ultimately the question was, does attending the institute improve listening skills? So there's really two parts to the question. Are the listening skills higher after the institute? Yes. How can we tell? We rejected the no. That's what we tested for. Listening skills are higher after the institute. Do we know that that was because of the institute? That implies cause and effect. When are we able to conclude cause and effect?
An experiment.
Experiment. Was this an experiment?
No.
No. Okay, so let's write that. While listening skills tended, I'm going to say tend, to be higher after the institute. We cannot conclude this is due to the institute, as this is not an experiment. Questions on what we have just carried out? Okay, so first thing I need to tell you is how to do a confidence interval. So here is the confidence interval formula. This should be pretty intuitive. Like I said, it's similar to a one sample, just a different context. So you're going to do x bar d plus or minus t times standard deviation over root n. So there you go. Your homework has both a confidence interval and a hypothesis test. I don't know how many of each, so I'm just letting you know you have both in there. Okay, before I show you how to do this on the calculator, I want to point out a few things to you. Did you notice that with the data I gave you for this problem, you could have carried out a two-sample procedure? You could have treated the pre-test as one sample and the post-test as a different sample, and carried out a pre-test procedure or a two-sample procedure like we did previously. You all with me? On the AP test, oftentimes that will be the case. You will be given sample 1 data, sample 2 data, and the difference. So they're going to give you enough information that you can choose the wrong procedure, that you can choose a two-sample when it should be matched pairs. So that is something to be aware of, is that oftentimes you'll be given enough information to carry out the wrong procedure. So we need to be very cognizant of, are the samples independent or dependent? Last thing to tell you is the reason we do this is because if we had carried out a two-sample procedure instead, if you carry out two-sample instead of matched pairs, sometimes you will find a difference that's not really there, or sometimes you won't find a difference that's there. So you could end up getting different results if you choose the wrong procedure. But basically, are the samples independent or dependent?